In our next example, we are dealing with these different trigonometric expressions, and we're told to factor each one. In part A, we are tasked with factoring secant squared theta minus 1. Now, one of the interesting things to realize here is that this is very similar to x squared minus 1, which could be factored into x plus 1 times x minus 1, right? Because in reality, the first term over here is squared. So something squared minus something else squared, when in reality 1 right here, you can consider that to be the square of 1 itself. So in reality, what we're dealing with is something like x squared minus 1, where x is equal to the secant of theta. So this is a little note that I'm going to go ahead and write for myself, because in reality, all I need to do next is factor out this expression, given that it's following that format. So all we would have to say here is that this is going to be equal to secant theta plus 1 times secant theta minus 1. And that's going to be the answer in this case. Now for part B, we have a little bit more involvement to consider here. So the question in part B says 4 tangent squared theta plus tangent theta minus 3. Oh, the box disappeared. Okay, let's bring that back. All right, so in this next part, for part B, we have 4 times tangent squared theta plus tangent theta minus 3. And again, this is really similar to the polynomial expressions that would follow this format, ax squared plus bx plus c, which you would then have to factor to get some product of binomials to go ahead and figure out what that final answer is going to be here. And in this scenario, what we can do is allow the variable x to be equal to tangent theta, so that we can rewrite our problem as 4x squared plus x minus 3. Now, part of the reason I'm rewriting it with the variable x is to make it look a little bit more familiar, so that the actual factoring that we would have to do is a little easier to do, because it is back to algebra basics that we're going to have to tap into. So we basically have a polynomial expression now, where we'll just keep in mind that x stands for tangent theta, but we're still going to have to factor this the same way we would factor any polynomial in the past, where we'll start by using the x method to figure out what two numbers can give us a product of negative 12, since we do need to multiply the leading coefficient and the constant to get the product to consider. And the sum in this case is going to be 1, the number in the middle that sits with your x. So this number right here, which is a 1. So we go ahead and think about two possible numbers that multiply out to give you negative 12 and add to give you positive 1. And those two numbers are going to be 4 and negative 3. But because we have a leading coefficient that's not a 1, we have to divide the factors that we're taking into consideration by that leading coefficient. So we'll go ahead and say that one of the factors we're going to consider is just the number 1. So we're going to get x plus 1. And then the other one is going to be coming from this term here, which can't be simplified into a whole number. So we take the denominator and put it with the variable, and we take the numerator as the constant number. So we're going to get a factored form here of 4x minus 3 times x plus 1. But again, the x is actually a placeholder. It stands for tangent theta. So the last step we would have to do is bring back the tangent of theta into the problem. So our answer becomes tangent theta plus 1 times 4 times tangent theta minus 3. And once we have that written out and boxed up, we can call it a day because we finished the problem.